Hello and welcome to another free code session. My name is Jason Bach and I cleared up a couple of things. I got this to use. This requires preview features attribute, and that seems to have gotten rid of a fair amount of things that I was seeing before. So I'm just going to go with that for now. I was on the Discord channel and I got some answer. It's like, well, that's not a perfect answer, but I'm like, it seems to work for me. So I'm just going to go with this. So we're moving on to actual errors now. So let's see here. That's my son's summer camp stuff that he needs to do. So this is from type delegator, but we're going to generalize these into errors, hopefully that we can fix. So the first one here is this dynamically x-access member type. So if you go to line 690, it's right. No, we're not close. 690. Okay. And what's happening here is that we're casting it to 1. And I was like, why are we even doing this? This seems a little weird. And why is there a space here? I don't know. Do you know? I don't know, but there is. So the thing is, this is actually an enum that -1 is all. And the problem is, if you look at the second error, is that to cast a negative value, you must enclose the values in parentheses. So we could just do this. But you notice that, I think up above, yeah, we're casting all these values. And I'm like, why are we not putting just this name dot the value? Like, why are we doing this at all? So then I was looking up here, and this get typed constant value is saying, if we're trying to get the, how does this work? Again, you have to think about what you're doing, because if you get an array, then you might call get value, and that in turn would call get value there, and then that might be a type constant value, and then that might be a primitive, and then you want to get the value. If it's an enum though, which it is in this case, what we're doing is casting it to the type's name and then doing value. Okay. Now this is a little problematic because we want to get the name of that enum value. But this is all in the compiler. This is not reflection, so we can't be too cute about this. What we could do is potentially say, okay, well, let's see. Type constant value here. You got value dot, what else do you have here? You got value dot get default value. Call set method. Kind type value. The value for a non-count, but that doesn't actually get the name. What we could do here is just say, put this in parentheses no matter what. And that gets rid of this being positive or negative. Okay. So what are we going to do? You're right. We're going to write a test. Okay. So what we want to do is, well, geez, golly, gee willikers. Do I want to actually make a test right on the attribute data extensions? Yeah, because that's what this is. So I already have tests against this that say get namespace, get description. And like this case, yeah, we're doing a cast here. Now this is going to break all these because suddenly we're going to be putting parentheses around the 0, which I don't like. I really wish this would just be this one. You know what I mean? I wonder, could we come into here and put a breakpoint right there and then run this test and see what do we actually get when we run into that? You know what I mean? Because I'd love to actually put in the name of the enum, not the value there. That'd be much cleaner if we could do that. Because we see this one right there. You would think. So we have value as a type constant. And we just know it's a kind of this. We know the type is a my value. We know the value is this, but we don't know what the actual name is. You know what I mean? If I come back up here, we have constructor arguments here, which for some reason we can't actually get to because there's 7, and we do a raw view. That's the type. That's the array. This is the enum. There are no values. It's just a value. So we just don't even know. We'd have to do some kind of type. Yeah, name type symbol and good luck. So I think that's why I did what I did, because we don't really have a choice. Okay. But what we could do here is say, do like a description. Where are we getting my value from? Well, it's up here. I must have this set up to actually grab in that thing, type, get attributes. I must be doing that. So let's have get description with negative enum value. Okay. So we're going to come up here and say this negative 1, which is going to be equal to -1. This one is going to be equal to 0. That one is going to be equal to 1, and another one's going to be equal to 2. We're just going to be explicit with our valuing here. Okay. And let's do this. So I think that's a little bit more readable. Okay. So now we're going to come back down here, and we want to say that this is a -1. Okay. And what we should see here is my value -1. But what we should also see here now is these. Okay, so anywhere where we're doing a cast, we want to put parentheses here, even though it's ugly. If there was a way to do this, I would love to see it, you know, but I can't figure that out off the top of my head right now. And then there should be a my value here. Generated code is not always the prettiest code. Okay, so then we're going to come back to here, and we're going to say anytime we run into a typed constant of an enum, we are going to put the value in parentheses. Okay, so now if we come back to our extensions tests here, there. Let's run all these and see what happens. And now they all pass, which is good, because now we've fixed this problem here. Okay, so dynamically, we're going to put this in our list, fixed. Error. Enums with negative values are now, we're causing, because that wasn't the problem here, because we were able to use it before. And this one. And now that's fixed. Okay, so we got that fixed. So we got that going for ourselves. So let's do git commit or stash. Now this might also break some code if there's enum somewhere else that we're trying to verify. At some point I'm going to have to rerun everything. Fixed can issue negative enum values. Okay, we got that now. Now this one's going to be interesting. Let's look at 924 first. Yeah, this iterator state machine. Yeah, neither one of these are going to be fun. If I come back over here, intrinsic attribute, this is 745. I don't know what intrinsic attribute is. Let's look it up. Yes, I changed all those. Okay, so .NET intrinsic attribute. What is that? That is in self-call intrinsic. I'm trying to figure out what exactly it is. Doesn't exist on the common attributes page. Intrinsic marks methods, properties, fields, and can be potentially optimized. You should only use it in an internal class, and only in the case when you want to propose very specific JIT level optimizations for it. It can be optimized. So I bet if I go to source.net and I look up intrinsic attribute, I'm going to find it. I bet it's internal. Yep, it is. So, but this actually leads to an interesting case, which is, can I actually see this from my assembly? I don't know if I'm actually making a check on any attributes to say, can I see it from the current assembly? And I bet that's what the real problem is. So let's do a little bit of digging here. This one's going to be fun to test because I need to make an assembly that doesn't expose internals to, and one that does compile those and use those from another assembly. And I kind of think I have tests that do that somewhere, because I thought there were like extensions to say can be seen. Yes, so there is so I'm doing this somehow, but I already have this in here somehow to say, yeah, I'm building something here and I'm getting the symbol, and then I'm creating another compilation that tries to reference the containing syntax tree, containing reference, containing compilation. Somewhere here a symbol's got to be used. Can be seen by containing assembly. Yes. So we just do like a real quick containing, build it all up, and then we see, can we actually see it, and is it true or false? I don't know though if we are actually ever doing a test on attributes to say, if I'm going to include attributes on a member, then I should check to see, can I actually see the thing in the first place? You would think that that'd be something you want to do. So we have to do something somewhere to say we are getting a list. We're getting the, somewhere in here in the builders, we're saying, for example, if I go to create and I go to mock method value builder, there's got to be something within here, attributes. Yes, so I say get attributes. Okay, where's that? Well, that's on the symbol. So, you know, I got that going for me. So, yeah, I don't even check to see if any of these are visible at all whatsoever. I just say attributes. This is a immutable array. Where is this happening? Attribute data extension. So I have attributes here, and then I say, okay, we can't emit attributes that are compiler generated, right? So the attributes that we want to emit are these. So we want to say, well, the attribute class is not null, attribute class, and it does not have any compiler generated attributes on it. Okay. What we also want to say is, can this attribute be seen? Because this is, I think, a type, yeah, name type symbol. So we want to say this and that. But I bet we also want to say something like attribute class can be seen by containing assembly. Now, what's the containing assembly? Compilation assembly, I think. There. If this would do it, that would make it really simple. Okay. That would make it extremely simple. But I don't know if it's going to actually let me do this. And I really need to test around this. Because the compilation itself, that is the thing that's being compiled, yes. So anything that's being called with can be seen by containing, I would imagine they're all passing in compilation assembly. Yes. Well, we are here because we just added that in here. So it doesn't mean much, does it? Where are we calling this? Containing assembly of invocation symbol. The IAssembly symbol. Is that the right thing? I don't want tests, I want this. Okay, so that has to be passed to me on mock information. Who gives me that? Containing assembly symbol. This goes to generate mapping. Who gives me that? Compilation assembly. So that is the right thing. Okay, I thought that was right, but it's good to check. So what we want to see is, can we actually see this attribute class? And in the case of an intrinsic, I bet we can't. And so then we would want to filter that out along with attributes that are not visible to the current compilation. Good thing I'm passing that in there, patting my back, because I don't know why I anticipated that, or I probably needed it here somewhere, but it worked out for me, so that's good. Okay, so we have that in here. I would really want a attribute data extension here, somewhere in here, to do something like what I was doing with can be seen by. Okay. So this is where I want to do something where I basically am compiling something here, right? And then we see symbol can be contained by is protected internal. But these are all because the symbol, the containing symbol is, the containing assembly is the same one as the symbol it's coming from. So all those should be true, which makes sense. But now we're doing stuff that's like is true and is false because we want to be a little bit more. This is just the symbols and the containing symbols. This is not for attributes. We really want to make sure though that we have a way to say here that we are trying to do something from a different assembly, a different compilation, where we could not see that attribute. And this is getting all the attributes because we are parsing the code that we are getting and we are just saying, give me all the attributes. But we are not determining what a description would look like. And that description is from here. So we want to reference an assembly that has a that has an internal, but yeah, how do we do this? How do we do this cleanly? I know I can do it. It's just, how do we do this cleanly? Because right now we've just been saying, I think I'm just being lazy. This is one of the parts of being lazy. Because we have a symbol here, and now we're saying, could that symbol just be seen by the current containing assembly, which is just this code? And unfortunately, the way we're doing it with attributes is we're embedding it within a, yeah, I don't even know what I'm saying here. It's kind of funny that those attributes actually show up because they're on the metadata, but we don't want them to be on any of the subtypes because we can't see them ourselves. So what's the right way to test this? What is the right way to test this? I would love to, yeah, there's no other way to do this other than to create an assembly that you make a second tree from, and then like there's no metadata reference create from image, is there? No. That's bytes, that's a stream, and this is a file of which we have none. So those are references though that we want. If I say a compilation here, could I say syntax trees, metadata references? Yeah, how do... These are by assembly symbols. How could I actually do this so that I'm... I think I've been saying the same thing for the past 5 minutes. How do I... Did it refocus again? Stop that. God, I really hope it's not doing that on my camera too much. That would be annoying. This is compilation. Can you say... Give metadata reference to the assembly symbol? I don't know if you can actually get a metadata reference to yourself. Can you? It says there's a one overload, which is kind of funny. Metadata to metadata reference creates a metadata reference for this compilation. Encouraging, encouraging. Okay, so let's come into here and let's say, let's make a test. Public static void get description. Yes, we would get the description would be nothing, right? Because we wouldn't have anything. If I come back up here to my attribute data extension, we return a string empty. Yeah, so we wouldn't get anything. Maybe that's why I'm sometimes seeing blanks there. Because maybe they just have a compiler generated attribute in them. Get description when attribute cannot be seen. Okay, so what we want to do is create a compilation with an internal attribute, internal. And well, how could we even put it on it? We find it in that thing, but if it's internal in one assembly, we couldn't even use it over here legally. That wouldn't be correct. It wouldn't even compile. Like I can't say here intrinsic. Okay, even though it might, no, it doesn't even find it. This is in system runtime compiler services, but it's not even going to be able to find it. It's going to say, yeah, it doesn't exist. So, okay, fair enough. But we couldn't even do that. That's going to give us an error. So if I get a description, if it's internal to itself, that's my wife doing something. Squeaking noises. If it's internal to itself, well, that would work. But we're trying to say we're pulling the attribute list from an assembly that we don't actually... Tune in next time. I'm near my limit anyway, and I need to do some other stuff today. So, yeah, I think what I would need to do is have a compilation that is a compilation that has an internal attribute and has a method that's marked with it. And then I can have in the second one invoke that method. And then I find I find the symbol representing that invocation of that method. I get the attributes from it, and I should be able to show that I get a string.empty. So let me see if I can get that down here. If I say var code, internal code looks like this. Okay, so we're going to do something like internal sealed class. You can not see this attribute. And we could do more on it to be correct, but we're not going to. Okay. We'll say you're using system. Okay, and then we're going to have a public static class test, doesn't matter, which has a you cannot see this on it, public static void run. It does nothing. Okay, so that's our first one. And so what we want to do here is do something like this. Okay, so we're going to take our internal code, do all that. We're going to call this internal. Okay, just internal syntax tree. The references don't matter. We can kind of leave those out here because we might need those for the second one. Okay, and then we want an internal compilation. Okay, now what we want to use is var, we'll call it external code. Okay, and what that does is and the recording crashed on me again, so I have no idea how much time left, where I stopped. So yay, Camtasia. Okay, so we're going to call run here, and all we're going to say is test.run. Okay, and we're going to make sure that we're referencing. Okay, so we're going to say here, we're going to say external syntax tree. External is going to be our external code, and then our external compilation is going to be references, but we're going to concat onto this a internal compilation to metadata reference. Compilation reference to to metadata reference. I can't add assembly name, syntax trees, metadata references. You cannot reference another. Even here's the funny thing. Talk about bad, naming. External. This says to metadata reference. Like that just doesn't make any sense. Metadata reference here gives you a compilation reference back. Okay. And these references here, create from file, these are all portable executable references. Oh, okay. So we're kind of colliding a little bit here, because I bet a portable executable reference, if I click on this, is a metadata reference. Okay. So what we need to say here is where select as metadata reference. Now it should work, because these are all metadata references. So what's the as metadata reference? And what don't you like now? Cannot convert Microsoft concat. Can't I just say add? I want to concat. Fine. A new array of. Yeesh. There. Now you shut up. Give a little balance there. So we're basically saying the same references, except we're concatenating on. Okay. Now, what I want to do is find off of. I want to find the var external. I know this episode's going long, but we want to see will this get semantic model off of the external syntax tree, and we'll say true here. Okay. And now what we want to do is get a method invocation. And I think I'm going to stop here, because I can't think off the top of my head. What I want to do is get a a invocation. Like here if I say syntax visualizer, this is an invocation, right? An invocation expression. Yes. And so what I want to say is var internal invocation is equal to on this get the root descendant nodes true dot of type, because that's what this is, right? This is an invocation, right? Invocation expression syntax, yes. Single, because there should only be one. Okay. Now, what we want to say is get var internal method. And this is, so we want to say here model external model. I'm going to do the wrong one. Get symbol. Or we just want to say symbol here, right? Get symbol info. What would happen? Let's stop right here. Let's just see what happens here. Syntax tree is not part of the compilation. Oh, well, that's true because it needs to be external here. Amazing that when you don't, oh, stop. Oh, no. We want the internal referenced. Okay, that makes sense. Now, what does this give? Test.run. What does this do? Anything? Test.run. Well. If I say internal method symbol, get attributes, what do you give me here? Well, you know, that's great. I'm glad that it's a length of 0. You cannot see this. Okay. Well, I'm so close. Let's just try to finish this out. So what I want to see here now is off of here, I want to get the internal method symbol, get attributes, get, this is an immutable array of attribute data. What does get attributes give me? Immutable array of attribute data. Why would you not be able to see that? Immutable array of attributes data. Get description. The compilation off of the external compilation, and why do we care about attribute targets? Targets. Oh, that's if we want to say the actual target, and we don't care in this case, so we're just going to leave it as this. Assert that this whole thing, which we know to be true, is there like string empty equal to string.empty. We should not be getting anything. Does this compile? It does. All right, I'm going to end the episode here, but this should fix this problem where we see this. So I think now we're down to just this type expected thing, but we're going to fix that. We're going to figure that one out in the next one. So thank you all for watching. Leave comments and questions below. See you in the next episode.